So again, I've got this lump of a region sitting on the positive x-axis, and I'm going to rotate it around the y-axis, just like on a pottery wheel. And I want to integrate to find its volume. Spoilers, we will be using an integral here. What would happen if I chopped up just a little piece of the x-axis? Imagine some vertical line segment sitting right here where my mouse is. Well, then that vertical line segment would be wrapped all the way around the y-axis, and I wouldn't get a circle like I did last lecture. I'd get a different shape. So the shape I would get is this cylindrical shell, or I'll just call it a shell. Now, if I wanted to give this an actual volume, my cylindrical shell needs to have width to it. So this cylinder really has two different radii. R1 is my smaller radius. That tells me the radius for the hole in the cylinder. R2 is the larger radius. That tells me the radius for the outside of the cylinder. I also need to keep track of the height of this cylinder, but the thickness, the delta R, delta just means change or difference. The delta R here is just the difference between R2 and R1. So let's find the volume of this cylinder. Well, we can take the volume for the larger solid cylinder, and we will subtract the volume of the hole, how much is missing. So this would look like this equation. My total volume is going to be the volume of the outside cylinder minus the volume of the hole. Each of those uses the cylindrical volume formula from last time, pi times the radius squared times the height. Well, it's the same pi in both places. Pi is a universal constant. It's the same height in both places. So my volume here is going to simplify as pi times quantity R2 plus R1 times quantity R2 minus R1. We've used difference of squares formulas here, times the height h. And with a little bit more trickery, we're going to call this 2 times pi times R2 plus R1, all on 2, times times h times R2 minus R1. There's a reason why we're writing it out this way, because when I go to take more and more shells, right, I'm thinking of this as being part of my Riemann sum, then my R2 and my R1 have to be getting closer together, right? My delta R's have to be getting smaller. This is directly analogous to the widths of my slices from last time getting smaller. Or if you want to go back even further for Riemann sums for area integrals, the widths of my approximating rectangles getting smaller. So my volume formula is going to look like this. The volume formula is twice pi times the radius r. And here I'm using r just to be the average of the big radius and the small radius. Okay. Times h, the height, times the delta r, the difference. So this is the formula for the volume of each cylinder. Let's build up that Riemann sum.